Hey everybody, and welcome to the next chapter, Boolean Indexing More. So here we're going to have a few other sort of miscellaneous Boolean indexing items that are quite important and deserve their own chapter. So we're going to learn how to do Boolean selection on a series. We're going to learn the between method can be used instead of an and condition. We're going to simultaneously select rows with Boolean selection and columns with a list of names with the Loke indexer. And then we're going to learn about how to find missing values with the is_na method. So let's start off with Boolean selection on a series. So far we've only done Boolean selection on a data frame. So just read in the data, and let's go ahead and select this. We want to select temperatures greater than 90. Let's go look at our data to begin here. So we're going to look at this temperature column over here, and we want to select temperatures greater than 90, but we want to do it on a series. So let's go ahead and select the series, the temperature column. We'll just call it temp. All right, so we just have a series now. So I want to show you how to do Boolean selection on a series. So this is not quite as interesting, and it's not something you do as much, but you can certainly do Boolean selection on a series. It actually happens very similarly as it does with a data frame. So the first thing you do is create a filter. You create a condition. So it's there's not as much as you can do because you're only working with one column of data. And since you've already extracted the column as a series, there's no reason to use the selection again, bike's temperature. You can go straight to temp. So let's just select all of the rows greater than 90. This is just so we can see that this is working. So filt will have true or false based on whether the temperature is greater than 90. And then we just simply to do the selection, we start with temp, we use just the brackets, and we pass it in filt. Now, you can see here we only have temperatures greater than 90, so it looks like it's worked. Previously, I said to use .loke or iLoke when doing selection with a series. This is an exception when you're doing Boolean indexing. And this is, I believe, this is perfectly fine because this is what is standard, and so if you have a Boolean series, you can go ahead and drop it in just the brackets, and it'll work just fine like this. So you don't have to you only have to use iLoke and Loke when you're actually selecting by label on a series. All right, so we can also do more complex Boolean, multiple conditions on a series. Let's go ahead and do that. Let's go ahead and copy and paste this. All right, so let's do temperatures less than 0, and we'll say this is filt 1, and then we'll do filt 2. We'll say temp is greater than 95. So either it's going to be cold or very hot, and we need to make our filter. We need to use the ampersand to combine the two. So filt 1 and filt 2. Then we're going to just drop filt into the temp series under the brackets. And so this should only return us temperatures, or. So that would actually, so let me just go ahead and run this. This is a mistake, but this will return us it's impossible to be less than 0 and greater than 95. So sometimes when you're doing videos, you are nervous and you do something completely stupid like this, but we can fix this. So here's the or operator, the pipe symbol, which will be used to create that condition either less than 0 or greater than 95. So now we have a few temperatures. The temperatures will only be either greater than 95 or less than 0, and the head of this has verified that. Okay, let's move on to the next section. So our results here are the index here is not very helpful in determining like what time of year it is. So these are simply, this is just the default index. So let me show you how the index can help out a little bit here and providing us a little bit more information. So we're going to go ahead and read in the bike's data frame again. We learned about parse dates, which will turn the anything that's a date time into an actual date time, and instead of just having pandas keep it as a string. So we're going to put the start time into the index here, just so we can have a label for each row. Now this may not be unique, but in this case, it's okay. It is very descriptive of the row. It gives you exactly when the ride occurred. So let's go ahead and do this. So here we have start time in the index. It is not a piece of data anymore. And if you look to the right a little bit, here we go. Stop time, it used to be right here. So start time used to be right before stop time. It is no longer there. It is in the index. So it is now labeling each row. So you certainly could have duplicates here if two people checked out a bike at the same exact time. But we're not going to worry too much about that because we just want to have a nice label here. All right, let's go ahead and select the temperature series again. So here we go. We'll just select temp again, or it's temperature, sorry. And now our bikes data frame has a label that is gives us more information than just the range index. So now we can see when we have some metadata here, which is just the time of when this ride took place. All right, so let's go ahead and I'm just going to copy and paste this code over here. So we use the same variable name, so it should work. So now when we filter out those less than 0 and greater than 95, the time of year, hopefully will make sense. So we're in North America, so it looks like August 2013. That's during summer, and then we have down here, looks like we have winter, December, January, where it's cold. So just a little extra information to help you understand that. Okay, let's move on to the next section. And I want to talk about a method called the between method. So this is a new method, and it works on a series. So let's take this temperature again. So let's say we want, instead of doing, say we want to find all temperatures between something like 50 and 60 degrees. Now you can do this with an and operator. No, an and operator, so I'm getting myself confused here. So you can do something like this. We can say temp greater than 60, or let's say 50, ampersand, temp less than 60. So we want to find all rides where the temperature was greater than 60 and it was less, or greater than 50 and it was less than 60. So this is perfectly fine. So that will do that, and that's simple enough where we can keep it in one line. And then we'll do bikes of filt, and we should get, well, you can actually apply it to the whole data frame, but I was meaning to apply it here just to the series. So either one, you can filter either the series or the data frame with the same filter. It'll work the exact same way. So you should have only temperatures in the 50s. Now, there's a slightly different way of doing this, and so there's a between method that you can use on a series. So if we press Shift Tab, we'll read the documentation, and it has two parameters, left and right. So, and this one is also important. It says inclusive is true, which means that this will include the left and right numbers. So if we do 50, 60, this will be inclusive of exactly 50 and of exactly 60. So you can make it inclusive equals false if you want it to be strictly greater than and strictly less than. But here we'll just keep it as the default, and we'll get should be the same results unless we have, I suppose there actually obviously could be a temperature of exactly 50 degrees in here or exactly 60. So this saves you a little bit of code. It's not really necessary. It doesn't really give you any more power, just kind of makes it a little bit more readable, I think. So it's something that's okay to know. And so feel free to use the between method if you want to shorten up, some and condition like this. All right, let's move on to something more important. So we're going to learn about simultaneous Boolean selection of rows and column labels with Loke. So all of our Boolean selections so far on a data frame has returned the entire data frame. Okay. So, for instance, let's go ahead and do this. So we have filt. So filt is above here. So let's go ahead and just copy this just to show you an example. So here's filter. So say we're only selecting data between 50 and 60 degrees. All right, so that works out. So if we look over here, let's just go verify. Temperature is over here. 54 looks good. Now, with just the brackets, you cannot simultaneously select rows and columns. But this is a perfectly, a common thing to do, is to filter out the rows, but you only want to return a particular set of columns. So let's say we want to get the temperature and events column. So let's go ahead and do this. So we want to select rows where temperatures between 50 and 60, but we only want the temperature column and the events column. Okay, so let's make a list here. And to do this, you're going to use the Loke indexer. So Loke, remember, does simultaneous selection with the rows, calls. So filt will filter the rows, and calls, it works on the columns. And I need a comma there. So filt, so rows, calls. So I could have titled this rows if I wanted to. That's fine, but I'm going to just use filt because it is a filter. So let's go ahead and do this. And now we just get back to temperature and events column. So it shortens up the output considerably. So this is quite a useful thing to simultaneously select, use Boolean selection for the rows and then use labels for the columns. So you have to use Loke here. Remember, Loke is an indexer that works by label. It also works by Boolean selection. So that's one exception to the label. You can use Boolean selection, but if you're trying to select, otherwise you have to use a label. So a list of labels is perfectly valid. So very useful here to shorten up the data frame output. If you don't want all of the columns, you just want a subset of the columns. So use Loke and pass it in the filter for the rows and the columns, whatever columns you want over here. Of course, you could have just done you don't even need a list. You could just do temp, and that's not the right word. So it's actually temperature. So this will just return this as a series since it's just a single column over here. All right, let's move on. We just did that. I want to show you another thing you can do. We can also do column-to-column comparisons. All right, so all the comparisons we've done so far has been from one column to another value, such as we've done the trip duration column to a value like 1,000. We've tested it whether it was greater than 1,000. Or we did, whether the events was cloudy. But you can also do column-to-column comparison. So take a look at this. Let's look at this variable dp capacity start. And there's one that says dp capacity end. So this is the capacity of the bike rack at the beginning and the end. So whenever this rider picked up their bike, there was 11 bikes there, and then when they brought it back, there were 15. Okay, so we can do column-to-column comparison instead of just column to a single value. So let's go ahead and do this. So let's test out. Let's make a comparison such that, what if we wanted to find all the rows where the capacity start was more than the capacity end? So you can do this. So we'll grab each series. So here we're going to make the comparison. dp capacity start is greater than dp capacity end. So we can just see that. We can see where in our data frame we had a true value and where we had a false. So we can assign this to a variable filt. And then we can just pass the filter into the brackets. And now we see here that, we can verify now, dp capacity start better be greater than dp capacity end. So 31 is greater than 19. So that looks good. Now, this is a good case to return only the dp capacity start and dp capacity end columns. Let's go ahead and do that with what we just learned with the Loke indexer. So there is a capacity start, and we'll just use this, make a list. So let's go ahead and do the Loke indexer. So filt, calls, And now we will get just the start and end column, so it makes it much, much easier to see the comparison. And we can just do dot head here. So this is column to column comparisons, something that you'll also do. All right, moving on. One thing is Boolean selection with iLoke does not work, so you cannot do, you cannot do simultaneous selection with the rows and then select by integer location. So the Pandas developers just decided not to do this. It would not be very common anyways. So if you have the integer location, you have to actually, find the column name of that integer location and then just use that with Loke. All right, so I want to talk about the isNA method. So we're going to use this to find missing values in our data frame. All right, so if you call a isNA on a column such as DP capacity, let's go back here. Let's find all the missing values of this particular column. So isNA. So what isNA does, it literally asks each value in this series, are you missing or not? So if it is missing, it'll return true. If it is false, it will return, or if it is not missing, it'll return false. So this returns a Boolean series. So when you have a Boolean series, you can do Boolean selection. So this creates a filter for you. Now, visibly, we can't see any true or false or any true values. So, there's 50,000 rows, so we're not inspecting all 50,000. So instead, we'll just assign this as a filter. So it's just a normal filter. It has the same length as the data frame. And then we can pass in the filter over here to bikes. And now we can get, see here. Okay, good. So DP capacity, there are in fact some missing values. So NaN is the missing value, representation for float columns. So this stands for not a number. So there are a few rows. This actually does all of them. So there's only a handful of rows over here that do have missing values. And of course, you can use .loke here. And calls is still, I believe, yes. Calls was defined above as the start and the end. So you can see where the missing values for capacity start was. And interestingly enough, it is known what the end is for those that don't know what the start is. Okay, so that's kind of cool. Missing, it is a method. It returns a Boolean series isNA. All right, just a little summary here. So it is okay to use just the brackets when you're doing Boolean selection on a series. Boolean selection on a series is quite simple, right? You only have one column of data to deal with, but it's certainly possible. If you want to do simultaneous row and column selection, so you want to select rows by Boolean selection and then select columns by labels, then you use Loke. So that is a common thing to do, and it's something that you'll definitely be doing. The between method is a shortcut for an AND when you're searching between two numbers. So it works between numbers, numerical columns. You can do column to column comparisons instead of just column to a single number. And then the isNA method returns a Boolean series. So you can use that to filter to see exactly where in your data the missing values are. Okay, so that wraps this section, Boolean indexing more. All right, if you want to learn more, please consider purchasing the book. It's called Master Data Analysis with Python. It's a fantastic book. I worked extremely hard on it. This is volume 1 of a 3-volume set. There are 600 pages, 300 exercises, multiple projects, and everything inside has these detailed solutions. So you will learn an amazing amount, and by the end, you should be able to master using the Python programming language to do data exploration. All right, that does it for this, and I'll see you guys in the next video.